Nd-YAG laser. It is a solid state 4-level laser. The active medium in this laser is yttrium aluminum garnet doped with triply ionized neodymium ions. The active center here is neodymium ions. The pumping method used in this laser is optical pumping. The pumping source is generally xenon or krypton flash lamp. The optical resonator consists of two polished silver plates. One of them is totally reflecting and the other is partially reflecting. The power output of this laser is 2 into 10 power 4 watts. Nature of output is pulsed or sometimes continuous. Wavelength of the output is 1064 nanometer, which lies in the range of infrared. Principle of Nd-YAG laser. The active medium in this laser is Nd-YAG crystal in the form of a rod. Some of the yttrium ions in the crystal are replaced or substituted by neodymium ions, Nd3+. The neodymium ions are raised to the excited states, either E3 or E4, by optical pumping using the flash lamp. During the transition from metastable state E2 to the ground state E1, a laser beam of wavelength 1064 nanometer is emitted. Construction. It consists of the active medium, a flash lamp and a resonator cavity. Working principle. In Nd-YAG laser, the active medium is crystalline substance of yttrium aluminum garnet doped with neodymium Nd3+ ions, cut in the form of a crystal rod. Due to doping, some yttrium ions are replaced by neodymium ions. These Nd3+ ions are active centers for laser action. When the flashlight from the krypton flash lamp is allowed to fall on the laser rod, the Nd3+ ions present in the ground energy level E0 absorb the light photons or raised to the excited level E3 or E4. The corresponding wavelengths for these transitions are 0.73 and 0.80 nanometer respectively, as illustrated in the energy level diagram. The excited energy level E3 and E4 are highly unstable and the lifetime is very short, of the order of 10 power minus 8 seconds. Hence, the Nd3+ ions undergo non-radiative transition from E3 or E4 to the metastable state E2. As most of the neodymium ions are in the energy level E2, population inversion is attained between the levels E2 and E1. When an ion de-excites by the spontaneous transition from E2 to E1, it emits a photon of energy h nu, which is equal to E2 minus E1. Then the laser action is initiated. This emitted photon triggers a chain of stimulated photons of the same energy. The photons thus generated travel back and forth between the two mirrors and grow in strength. Within a short period of time, the number of photons multiplies. Upon attaining the sufficient strength, the intense laser light of wavelength 1064 nanometer, which is in the infrared region, is emitted through the partial reflect. The subsequent transition of Nd ions from the energy level E1 to the ground level E0 is rapid and non-radiative. Advantages of Nd-YAG laser. It has a high energy output and repetition rate. Population inversion can be easily achieved. It can work in continuous as well as pulse mode. There are some disadvantages in this laser. Proper doping of Nd3+ ions is required. The power output is very low. Applications of Nd-YAG laser. It is used in engineering field for transmitting signals to longer distances. It plays an important role in remote sensing applications. This laser is mainly used in cutting and welding of steel and alloys in industries. It is used in range finders and illuminators. In medical field, it is used in endoscopy, urology, neurology, neurosurgery, ENT, gynecology, dermatology and dental surgery. It is used in ophthalmology for cataract surgery. It is used for hair removal. It is used in the treatment of minor vascular defects such as spender veins on the space and legs.